Okay, Calc Kids, this is day 2 of review. We're on number 14. Let me look down and see. I want to try to get through, I don't know how many, we have 40 questions. Let's see if we can get to like 26. That'd be a good cutoff mark. And then do chapter 3 stuff and chapter 4 stuff tomorrow. So starting with number 14, we're still doing log stuff. And so using logs to solve for x. And we have to use a log to solve for x because x is in the exponent. So the first thing that I'm going to do is I'm going to divide by 3 to get him gone so that e is the only thing left on that side. So I have e to the negative 5x. And then equals 27 divided by 3 is 9. And then what I can do to get rid of e is I can do ln, and that will cancel those out. So the negative 5x will come down in front, equals ln of 9, and then I'm going to divide by negative 5. So I can type this in all at one shot if I want to, but make sure that if your calculator opens up a parentheses for ln, that you close it before you divide by 5. Let's see if I can get my calculator to do this. Okay, and I got negative 0.4394. Typically when you're solving for logs, they want you to go out like 4 decimal places. Okay, so that's what I got. Hopefully that's what you got. Maybe I did something wrong, but, that's that. As we go through here, if you need to pause, I will say again, or put a star by a number. I will hopefully be back tomorrow. I'm planning on being back tomorrow. Number 15, I lied to you yesterday when I said we were done with limits. This is the last limit question, but they're asking you to analyze the graph. And so here we're finding the limit as x goes to negative 4. Okay, so negative 4 is like this spot right here. So we're looking at either this side or we're looking at this side. And since it is minus, that means negative 4 from the left. So on the left side, as we're coming in from the left side, what y value is it approaching for negative 4? And that is going to be, whatever it is, 1, 2, 3, 4, 5, 6. A y coordinate of 6. So the limit as x goes to negative 4 from the left is going to be positive 6. Positive 6. Okay. Now, just so you are aware, if I would have said, and I didn't, so you don't necessarily have to write this down, but if I would have said from the plus side, that limit is 4. I think he's going to a y coordinate of 4. Then if I would have said what's the limit as x goes to negative 4 both sides together, since these aren't in agreement, that would be a does not exist scenario. And then there's another question I could ask you about 4. I could say, like, what is f of 4? Which is not asking for the limit. It's just saying, what is the actual y value at 4? Okay, and since it's a closed circle here and not a closed circle here, the actual y coordinate at 4 would be 6. So hopefully that cleared everything up. This is the only question that I ask, but just so you're aware, like, that's how some of the other things fall into play. Okay? All right, next page. Now we're getting into derivatives. So whenever it says differentiate or find y prime or find dy dx, that just means take the derivative. This thing looks like I would maybe need to use the quotient rule, but since there's no x down here on the bottom, what I can do is I can write this whole thing as 2/3 x squared plus 5/3 x. And then I can just do the straight power rule, okay? So that 3, if there was an x in the bottom here, you bet I would have to do the quotient rule. But here I can just get away with that. I'm going to write up here, we have the power rule, we have the product rule, we have the quotient rule, and we have the chain rule. Okay, so the power rule, like x to the nth power, if I'm taking the derivative of that, is n x to the n minus 1. Okay, that's just kind of the general one. That's the basic one. That one you should know. The product rule, f prime g plus g prime f. and then whatever your f and g are. Quotient rule, f prime g minus g prime f all over g squared. And then the chain rule, if I have, let's say I'm taking the derivative of x to the n power where like I have a group of stuff inside there, that's when I have to use the chain rule. And what I will do is I still do n, x to the n minus 1, but then I take it times the derivative of x. So I take it times x prime. And we'll see that down below here. Okay, so those are all your rules if you want a summary of them. Let's go back down here. This is a power rule one. So all I'm going to do is take like this 2, multiply it down in front. 2 multiplied down in front is like 2 over 1. 2 over 1 times 2/3 is 4 over 3. X to the first power. Okay, because I subtract that exponent. And then this guy is kind of like 1 times 5/3 or just 5/3. X to the 0 power or just 5/3, okay? So this is his derivative, okay? You don't have to have the 1 here if that bothers you. You can get rid of that 1, but I just wanted to show you that's how the rule works. Technically, this guy would be called y prime because the derivative of y is y prime, and that is his derivative, okay? That's all we had to do there. 17 is asking for the slope of the tangent line. That is the derivative at the point x equals 3. So all we have to do is take the derivative and plug in 3. So, and this is a general power rule one again. So I'm going to take the 3 down in front. So that's like 3 over 1 times 2/3. That would be 6 over 3, and 6 divided by 3 is 2. Or one thing you could do is look at this like the 3's cancel. So 2 is all I have left, okay? So that would be 2x squared minus, this guy becomes 8x, and then the 7 goes away. And now I want to plug 3 in. So I'm going to put 3 here, and I'm going to put 3 here. And 3 squared is 9, times 2 is 18, minus 8 times 3 is 24, and that is like -6, I think, or something. Okay, so that one was just slope of tangent line. Now in the next one, we're going to do the whole equation of the tangent line. So equation of a tangent line, the equation of a line is y equals mx plus b. I just think like a linear equation. What does it look like? Okay, so here's our function, and we want at the point where x equals 1. Okay, we're going to have to do some funny business. But first and foremost, we want to try to find m. And we do that just like we did up here, is find the derivative, plug in 1. Okay, so my derivative is 4x minus 2. The 3 goes away. And now I'm going to plug 1 in. So if 1 goes in here, 4 times 1 is 4, minus 2 is 2. So my slope is 2. Okay, so now I'm at this point. Y equals 2x plus b, okay? And now I have to solve for b. And typically when we solve for b, we have to have an x and a y value, but I only have an x. Like I have 1 comma something, and I have no idea what that something is. So how do I know what to plug in for y? Well, we can find the y. We just have to get it from the original function, okay? So I'm going to, not the derivative, I'm going to plug the x coordinate. I'm going to plug 1 in here and 1 in here to figure out what we get for a y coordinate just in general. Okay, so 2 times 1 squared, 2 times 1 plus 3. This will become 2. This will become minus 2 plus 3. So I got just 3. 3 is going to be just the y coordinate, okay? 1 comma 3. So I'm going to plug 1 in here. I'm going to plug 3 in here. And then I'm going to solve for b, and then we're going to be done. So 2 times 1 is 2. Then I'm going to subtract that 2 over from the 3. And b will be 1. So final answer, y equals 2x plus 1. And that is my equation of my tangent line at that point. Okay, so like this graph is a parabola somehow, some way at x equals 1. This line right here, his equation is 2x plus 1. Okay, just so that you know what you're finding. You don't have to write that down, but that's essentially what you're finding is the equation of this line that is tangent at that point. Okay, all right. 19, differentiate. This guy we have to use the product rule on, or not the product rule, the quotient rule. So I'll get f prime g minus g prime f over g squared. F prime, the derivative of this guy is 3. G just by itself is x squared plus 1 minus g prime, this guy's derivative, is 2x times f is 3x. And all over x squared plus 1 squared. Okay, I am not going to FOIL him out, but I am going to do a little bit of work to the top. So If I distribute that through, that's 3x squared plus 3. And then I'm going to change this to plus, and I'm going to make the negative go with the 2x, which I guess isn't that big of a deal because I'm not really distributing. I'm just multiplying those together. But make sure that if there's a minus there, you distribute the minus through. So that will become minus 6x squared all over x squared plus 1 squared. One more thing, I can combine these two guys. So I've got negative 3x squared plus 3 over x squared plus 1 squared. That's not that bad. That wasn't that bad. That was the quotient rule. Okay. I need a drink of water. Okay. Number 20, find the derivative. You can certainly use the quotient rule on this one as well, but I'm going to do this. I'm going to move the 4, or the x to the 4th, up to the top. So this guy will become negative 3x to the negative 4th, because now he's in the, like, over 1, basically. So now he's in the numerator, but he is a negative exponent, and now I can just do the power rule. So negative 4 comes down in front. This guy will be 12x to the negative 5th power, right, because you're subtracting 1. And now if I want to fix him, I move the x back down to the bottom. So I get 12 over x to the 5th. And that's a lot faster doing it that way. If you have something simple like this, it's a lot faster doing it that way than if you were to use the quotient rule, okay? All right, they are wanting us to, on 21, to use the product rule on this. Technically, you could multiply it out and just do the power rule. But I'm going to use the product rule just so that we get like a refresher on product rule, because the one that I put on the test, who knows, it might not be able to be foiled out very nicely. So we'll just practice. F prime g plus g prime f. So this is my f, and his derivative, the 2 goes away, so his derivative is just negative 3. G is that whole thing, plus g prime, the derivative of that. Hey, this is going to come out nice. Derivative of that is just 5 times f 2 minus 3x. Okay, then I'm going to distribute him through. So negative 15x minus 3. I'm going to distribute him through. So plus 10 minus 15x. And then I'm going to combine like terms. So I've got negative 15x minus another, so that's negative 30x. And then negative 3 plus 10 is plus 7. So there is that, all right? So you could have foiled it and gotten that answer and then just done the power rule. If you want to do that to check your answer, that's like not a bad idea. But it might have been just about the same amount of work if you would have foiled and then taken the derivative. So I bet you would have the same number of steps. Whatever. Okay, find the derivative 22. Find the derivative. This guy is 1 minus t to the 1/2 power. That's what the square root does, okay? So this one is one where I have to use the chain rule. It's like chain rule is for composite functions. So this 1 minus t is trapped underneath of the 1/2 power, or underneath of the square root. So that's when I know I need to use the chain rule. Okay, so chain rule is kind of like power rule. He comes down in front. 1/2. I leave the 1 minus t to the 1/2 power, but then I have to take the derivative of this inside. And the derivative of the inside, the 1 goes away, but negative t becomes negative 1 for his derivative. And then oh, shoot. Yell at me. I have to subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. Now I take him times negative 1. Okay, so fix that exponent. All right, now, when I'm doing chain rule, I usually like to, because I know I'm going to have some stuff on the bottom, because I have this as a negative exponent. So if I take and find what's on my top and what's on my bottom, 1 is on the top and negative 1 is on the top. And if I multiply those together, that's negative 1. This 2 can go to the bottom with this junk right here. Okay, so I'm going to lump 2 to the bottom, and this is 1 minus t to the 1/2 power. He's to the positive 1/2 power now that he's down the bottom, but I'm going to make him the square root, and this is what my derivative looks like. Okay, so that was a chain rule. Usually, typically with your chain rule, well, not always, I guess. Whenever you have square roots in your chain rule, you're going to end up having to force that down to the bottom to get him to be a positive exponent. Okay, so that's how that works. Unless he's like the cubic root of something to the 4th power, then you won't have a bottom. Okay. All right, moving on, this next one, find the derivative. This one is like 12x to the 1/4 power. And this is not a chain rule because x is the only thing that's underneath of there. So this is just a power rule, and I can take the 1/4 down in front, and 1/4 times 12 is 3. X to the negative 3/4. If I subtract 1 from 1/4, that would be like subtracting 4/4 from 1/4. That would be negative 3/4. So this is my derivative, but if I fix him, the x is going to go back down to the bottom. So I will have 3 over x to the 3/4 power, which means the fourth root, this bottom number is the root, right? Like if I do the 1/2 power, this was square root, right? The bottom number always tells you what the root it is, and then this is x to the 3rd power. And you can technically write him like that, or you could write him as the 3rd power outside, whichever way. I usually just try to write him underneath when he's like that. Okay, so this is my derivative. That was not a chain rule, that was just a basic power rule, but putting your, fixing your exponent and making it positive again, okay? So that was my derivative. Where are we at here? We got just a few left. Okay, find the derivative. This guy is a product rule, but these are my two products. So this is my f and this is my g, except g, when I go to find g prime, this guy is a chain. So this is really a chain in a product. Okay, you'll have one of those. Typically, like on this test, I will only ever give you like the chain rule, the product rule, the quotient rule, the power rule, whatever. I will only give you those, but there's one problem on the test where I'll do something in something. And it's probably going to either be a chain in a product or a chain in a quotient. So just warning you, like we start with the product rule, and then as we do our g prime, as we take the derivative of this guy, we'll just have to incorporate the chain rule in there, which is not that big of a deal, okay? So I'm going to start with the product rule. Product rule is f prime g plus g prime, and this is the part that gets really icky. So I'm going to put a box around him so I know g prime f. Okay, so f prime is the derivative of this guy, so that is 12x cubed. Okay, that's what he is. The g part, x squared minus 3x squared. Okay, now here comes my g. So this is my chain rule. So when I take the derivative of this guy, the 2 comes down in front. This 2 comes down in front. I leave the inside. Now he is to the 1st power. But then I have to take times the derivative of the inside, right? Which is 2x minus 3. That's the derivative of the inside. Now at this point, I have a lot of people, if your g prime is really, like, has a lot of stuff going on, typically we get to that point and then we stop because people are like, oh, I'm done. Don't forget you still have f there. And that is 3x to the 4th. Okay. I'm trying to think of what all, I'm not going to simplify this all the way down, but let's put some stuff together. Because this is squared, I don't want to FOIL it out. So I'm just going to leave him 12, but I'm going to get rid of these parentheses. 12x cubed times x squared minus 3x, that guy squared. I don't want to FOIL any of that out. 2 times 3x squared, though, or 3x to the 4th, is 6x to the 4th, and then I'm just going to leave the other two bubbles the same. X squared minus 3x to x minus 3, okay? So those are both to the 1st power, so technically we could FOIL those out and then distribute the 6 through. I don't want to do that. The purpose of the problem is so that you know how to take the derivative, and if you get to this point, then you have successfully taken the derivative correctly, right? The derivative is the point of the problem, all right? So simplify him a little bit, like get rid of some of the parentheses, like from this step to this step. But if you can get it to that far, like you don't need to FOIL. I know that you guys know how to FOIL, so I'm not going to worry about that too much, all right? So that was probably one of the harder ones, a chain and a product, okay? It might be a chain in a quotient, so it'll be either chain and product or chain and quotient. I don't remember what I did, but there's that, okay? All right, 2 left. Find the derivative, sine and cosine. All right, so I don't have my sheet. I hope I do this right. If I do this wrong, remind me tomorrow, because I don't know that I remember the derivatives of all these, okay, these trig functions. But this is a product, right? We have 2 pieces. This is my f and this is my g. So I got to do the product rule again. F prime g plus g prime f. Okay, f prime is the derivative of sine. The derivative of sine is cosine of x. Then g stays cosine x. Oh, this is nice. I think I know what they're doing. plus g prime, the derivative of cosine, is negative sine of x. I know what they're doing. No, I don't know what they're doing. I don't know what they're doing. F is sine of x. So this, if I multiply these together, this is cosine squared x. This would be minus sine squared x. I was thinking that they were going to make this 1, right? Sine squared plus cosine squared is 1, but that's plus, not minus. So I don't think we can actually reduce that. And you people who have not had trig yet, like we haven't gotten into trig functions, so like you juniors, you wouldn't know that anyway, and that's totally fine. If you leave it like cosine squared minus sine squared, even if it did reduce, just leave it like that. But this one I don't think does reduce because it's minus instead of plus. Okay, so hopefully I did that right. I think that those are the correct derivatives, and that's what I got. So just leave him like that, but that was the product rule using trig functions. Okay, this last one is a chain rule. Okay, so this is tangent function stuck inside of the fourth power. Now, just so you know, this is actually the same as writing him as tangent to the fourth x. So if I would tell you, hey, take the derivative of this guy, I would write him like this first, right? Tangent of x to the fourth power. Maybe I should have done that so that you get the practice of writing him like that before you take the derivative, okay? Really, this one looks nicer because he doesn't have parentheses, but as far as it goes to like taking derivatives, this is written in like pre-chain rule format, right? That's like ready to do the chain rule because usually I'm used to having parentheses and then to an exponent, okay? So starting the chain rule, 4 is going to go down in front. So I've got 4 tangent x, he just stays in the middle, and that becomes to the third power, but then I have to multiply by the derivative of the inside, and the derivative of tangent, I think, is secant squared. Okay, you'll have to put a star by that if that is wrong, and let me know tomorrow, but I'm pretty sure that's secant squared. The only thing that I usually do on the chain rule is take this guy times the back guy, so 4 secant squared x, and then I have tangent x to the third power, and I can get away with not having this guy in parentheses because he is just one piece by himself, right? So if you want to put parentheses around it, you can, but that's what I got for that chain rule derivative, okay? Maybe we should have put can I go back through? This was a chain rule. Does this help if I put this off to the side? This was a product. I don't know if you need this, but if you need it, if you don't need it, shut the video off. But if you do need it, I'm going to put these off to the side. This was a chain and a product. Just so that you know. That's what I would do first, is like on each one of these identify. This is just the power rule. This guy is a chain. This guy is a product. You could have foiled it out and just done the power, but we did the product. This guy, we just did the power when we moved into the top. This guy was a quotient. And this guy, oh, that one was just a power. And this was just a power. And then the top guy was a power as well. Okay, so those are those rules. Follow along with those. We haven't gotten into any of the like crazy weird ones where you're doing like implicit differentiation where you have x and y's going on at the same time, or we haven't done any ln's. We'll get to that tomorrow. And those are all together kind of different rules, but these are just the straight power, product, quotient, chain. Okay? All right, that is all I have.